Accuracy, precision, and errors in measurement. We can't measure a physical quantity accurately by our sense, so we use different instruments to measure different physical quantity accurately. Instruments. An instrument is a device which assists our senses for measuring a physical quantity. Example: meter, scale, slide caliper, screw gauge, thermometers, barometer, etc. Least count. It is defined as the smallest amount which can be measured with that instrument. Now, least count of meter scale is equal to 1 millimeter, 0.1 centimeter, or 0.001 meter. Least count of slide caliper is equal to 0.01 centimeter or 0.0001 meter or 0.1 millimeter. Least count of a screw gauge 0.001 centimeter, 0.01 millimeter, 0.0000 meter, 1 meter. Error. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called error. Consider the true length of a rod is 3.56 meter, but measured length is 3.25 meter. Then error will be 0.31 meter. Accuracy. The accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. It states about closeness of measured value to the true value. Precision. It tells us to what resolution or limit the quantity is measured. It depends upon the least count of the measuring instrument. For example, true value of length 3.678 centimeter. First measurement L1 equal to 3.5 cm with resolution 0.1 centimeter, which is the least count of instrument, and the second measurement L2 equals to 3.38 centimeter with resolution 0.01 centimeter. So first measurement is more accurate but least precise, and second measurement is less accurate but more precise. Question: true length of rod 2 meter. First measurement L1 equal to 2.0 meter. Second measurement L2 equals to 2.00 meter. Third measurement L3 equals to 2.000 meter. Which one is more accurate measurement? Answer will be third, because third is more accurate and also more precise. Error. Systematic error. It tends to be in one direction, either positive or negative. Random error. It occurs irregularly and hence are random with respect to sign and size. Least count error. It is associated with the resolution of the instrument. Absolute error, relative error, and percentage error. First, true value. The arithmetic mean of the large number of measurement is taken as the true value of the measurement. In absence of any other method of knowing true value, consider the value obtained in several measurements are A1, A2, A3 n. Then arithmetic mean of measurement is given by A mean equals to A1 plus A2 plus A3 n by n equals to sigma I equals to 1 to n AI by n. Absolute error. The magnitude of the difference between the individual measurement and the true value of the quantity is called the absolute error of the measurement. The errors in the individual measurement is given as delta A1 equals to A1 minus A mean, delta A2 A2 minus A mean, and delta an minus A mean. This may be positive or negative but its absolute value denoted by mod delta A is always positive. That is, mod of delta AI equals to mod of AI minus A mean equals to positive. Mean absolute error. The arithmetic mean of all the absolute errors is taken as the final or mean absolute error of the value of the physical quantity A. It is represented by delta A mean. Thus, delta A mean equals to mod of delta A1 mod of delta A2 plus dash 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 mod of delta AN divided by n equals to sigma I equals to 1 to n mod of delta AI by n. If we do a single measurement, the value we get may be in the range A mean plus minus delta A mean. That is, A equals to A mean plus minus delta A mean, or A mean minus delta minus A mean less than equal to A, or A less than equal to A mean plus delta A mean. This implies that any measurement of the physical quantity A is likely to lie between A mean plus delta A mean and A mean minus delta A mean. Relative error. It is the ratio of mean absolute error delta A mean to the mean value A mean of the quantity measured. That is relative error delta A mean by A mean. Percentage error. When the relative error is expressed in percent, it is called the percentage error delta A. Thus, percentage error delta A equals to delta A mean by A mean into 100%. Question. The diameter of a wire as measured by a screw gauge was found to be 2.620, 2.625, 2.630, 2.628 and 2.626 cm. Calculate mean value of diameter. Absolute error in each measurement, mean absolute error, fractional error, percentage error. Express the result in terms of percentage error. A. Mean value of diameter. D mean 2.620 plus 2.625 plus 2.630 plus 2.6 divided by 5 equals 2.6258 centimeter. After rounding off, we get 2.626. Now, errors in different observation. Delta D1, D mean minus D1 plus 0.006. Delta D2, 2.62 minus 2.625 equals to 0.001 cm. Delta D3, 2.626 minus 2.630 equals to minus of 0.004 cm. Delta D2, 2.626 minus 2.628 minus 0.002 centimeter. Similarly, delta D5 we get 0.000 centimeter. Now, mean absolute error delta A mean mod of delta D1 mod of delta D2 mod of delta D3 mod of delta 3 plus the mod of delta and divided by 5. Finally, we get delta D mean equals to 0.0026 or 0.003 after rounding off. D. Relative or fractional error delta D mean by D mean 0.003 by 2.626 equals to 0.001. Hence, percentage error del D equals to delta D mean by D mean into 100 equals to 0.1%. Hence, D equals to D mean plus minus del D, 2.26 plus minus 0.1% answer. Combination of errors. MA. Error of a sum or a difference. Suppose A and B are two physical quantities with absolute error delta A and delta B. The sum is given by Z equals to A plus B without error. Now consider delta z be the error in z. Then z plus minus delta z equals to a plus minus delta a plus b plus delta minus b equals to a plus b plus minus delta a plus minus delta b, और z प्लस माइनस डेल्टा ए प्लस माइनस डेल्टा बी, और प्लस माइनस डेल्टा जेड इक्वल्स टू प्लस माइनस डेल्टा ए प्लस माइनस डेल्टा बी. So plus delta z equals to plus delta a plus delta b, or plus into under bracket delta a plus delta b, and minus delta z equals to minus of delta a minus of delta b equals to minus of under bracket delta a plus delta b. So maximum possible error in z is delta a plus delta b. Now for difference, z equals to a minus b without error, and if we consider error, then z plus minus delta z equals to a plus minus delta a minus of b plus minus delta b, or a plus minus delta a minus b plus minus delta b equals to a minus b plus minus delta a plus minus delta b, or z plus minus delta a plus minus delta b. Hence plus minus delta z plus minus delta a plus minus delta b. This implies plus delta z equals to plus delta a plus delta b, or plus of under bracket delta a plus delta b. Similarly, minus of delta z equals to minus of delta a minus minus of delta b equals to minus of delta a plus delta b. Again, the maximum error in z is delta a plus delta b. Rule: when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute error in the individual quantities. For example, T1 equals to 20 degrees Celsius plus minus 0.5 degrees Celsius, and T2 equals to 50 degrees Celsius plus 0.5 degrees Celsius. Calculate the difference in temperature and error. Here delta T equals to T2 minus T1. The 50 degrees Celsius plus minus 0.5 degrees Celsius minus 20 degrees Celsius plus minus 0.5 degrees Celsius. So delta T equals to 30 degrees Celsius plus minus 1 degree Celsius. So error, absolute error is always added. Error in product and division. A product, let z equals to a into b, is the product of two quantities a and b without error. Consider plus minus delta z with the errors in z, and delta a and delta b with the errors in a and b respectively. Then z plus minus delta z equals to a plus minus delta a into under bracket b plus minus delta b equals to a into b plus minus a into delta b plus minus b into delta a plus minus delta a into delta b. This implies z by z plus minus delta z by z equals to ab by z plus minus a into delta b by z plus minus b into delta b by z delta a by z plus minus delta a into delta b by z. This implies 1 plus minus delta z by z equals to 1 plus minus delta b by b plus minus delta a by a, and delta a by a plus minus delta a into delta b, or plus minus delta z by z equals to plus minus delta b by b plus minus delta a by a plus minus delta a by a into delta b by b. Since delta a and delta b is small, so product delta a into delta b can be neglected. Hence plus minus delta z by z equals to plus minus delta b by b plus minus delta a by a. Hence maximum relative error in z is delta a by a plus delta b by b. B. Division. We have Z equals to A by B without error. Now Z plus minus delta Z equals to A plus minus delta A divided by B plus minus delta B. This implies Z into under bracket 1 plus minus delta Z by Z equals to A into under bracket 1 plus minus delta A by A divided by B into under bracket 1 plus minus delta B by B. This implies 1 plus minus delta Z by Z equals to 1 plus minus delta A by A divided by 1 plus minus delta B by B. This implies 1 plus minus delta Z by Z equals to under bracket 1 plus minus delta A by A into 1 plus minus delta B by B to the power minus 1, or equals to 1 plus minus delta A by A 1 plus minus into minus 1 into delta B by B, because since 1 plus x to the power n equals to 1 plus nx if x is very less than 1, equals to 1 plus minus delta A by A into 1 plus minus delta B by B. This implies 1 plus minus delta Z by Z equals to 1 plus minus delta B by B plus minus delta A by A plus minus delta A by A into delta B by B. This implies plus minus delta Z by Z equals to plus minus delta B by B plus minus delta A by A. Hence, maximum relative error in Z is delta A by B, delta B by B plus delta A by A. Rule: when two quantities are multiplied and divided, the relative error in the result is the sum of the relative error in the multipliers. Example: the resistance R equals to V by I, where V equals to 100 plus minus 5 volt and I equals to under bracket 10 plus minus 0.2 ampere. Find the percentage error in R. We have delta R by R equals to delta V by V plus minus delta I or plus delta I by I. 5 by 100 plus 0.2 by 10 equals to 5 by 100 plus 2 by 100. Hence, percentage error delta R by R into 100%. 5 by 100 गुने 100 plus 2 by 100 गुने 100 equals to 5% plus 2% equals to 7% answer. Two resistor of resistance R1 100 plus minus 3 ohm and R2 equals to 200 plus minus 4 ohm are connected. A in series, B in parallel. Find the equivalent resistance of the series combination A and B parallel combination. Use for A the relation R equals to R1 plus R2 and for B 1 by R dash equals to 1 by R1 plus R2 and delta R dash by R dash square equals to delta R1 by delta R1 by R1 square plus delta R2 by R2 square. Solution: A. The equivalent resistance of series combination R equals to R1 plus R2 equals to 100 plus minus 3 ohm plus 200 plus minus 4 ohm equals to 300 plus minus 7 ohm. B. The equivalent resistance of parallel combination R dash R1 into R2 by R1 plus R2. Then 100 into 200 root 100 plus 200 without error. We get 66.7 ohm. Now, given delta R dash by R dash square equals to delta R1 by R1 square plus delta R2 by R2 square. Hence, delta R dash equals to delta R1 by R1 square into R dash square, delta R2 by R2 into R dash square. Putting all the values, 3 by 100 square into 200 by 3 का whole square plus 4 by 200 का square into 200 का whole square by 3 square. Solving, we get 12 by 9 plus 4 by 5 equals 12 plus 4 by 9 equals to 16 by 9 equals to 1.77 equals to 1.8 ohm. Hence R dash will be 66.7 plus minus 1.8 ohm with error. See, errors in the case of a measured quantity raised to a power. Suppose Z equal to A square equals to A into A. Then delta Z by Z equals to delta A by A plus delta A by A equals to 2 into delta A by A. Thus, the relative error in A square is 2 times the error in A. In general, if we have Z equals to A to the power P into B to the power Q by C to the power N, then delta Z by Z equals to P into delta A by A plus Q into delta B by B plus R into delta C by C. Rule: the relative error in a physical quantity raised to the power k is the k times the relative error in the individual quantity. Example: find the relative error in Z if Z equals to A to the power 4 into B to the power 1 by 3 divided by C into D to the power 3 by 2. Solution: delta Z by Z 4 into delta A by A plus 1 by 3 into delta B by B plus delta C by C into 3 by 2 delta D by D. Answer: the period of oscillation of a simple pendulum is T equals to 2 pi under root L by G. Measured value of L is 20.0 cm, known to 1 millimeter accuracy, and time for 100 oscillation of the pendulum is found to be 90 seconds using a wristwatch of 1 second resolution. What is the accuracy in the determination of G? Answer: G equal to 4 pi square L by T square. Here T equals to T by N. Delta T equals to delta T by N. Hence delta T by T equals to delta T by N by T by N. T delta T by N into N by T, or delta T by T. The errors in both L and T are the least count errors. Therefore, delta G by G equals to delta L by L plus 2 into delta T by T, or equals to 0.1 by 20.0 plus 2 into 1 by 90 equals to 0.027. Thus, the percentage error in G is delta G by G into 100, equivalent to 2.7 or 3%. Consider you measure the two quantities as A equals to 1.0 meter plus minus 0.2 meter and B equals to 2.0 meter plus minus 0.2 meter. Find correct value of under root AB. Let Z is equal to under root AB. Then delta Z by Z equals to 1 by 2 into delta A by A plus delta B by B. This means delta Z equals to 1 by 2 delta A by A plus delta B by B into Z, or equals to 1 by 2 into delta A by A plus delta B by B into under root AB. Putting all value, we get delta Z equals to 0.2. So correct value of Z equals to under root AB plus minus delta Z equals to 1.0 into 2.0 plus minus 0.2 under root 2.0 plus minus 0.2, or 1.414 plus minus 0.2 equals to 1.4 plus minus 0.2. Answer.